This conference will now be recorded.
Good morning, one and all. This is Rajesh from AC department. So our subject embedded system design. So as we discussed in our unit 1, the objectives, introduction, definition of embedded system. We have compared embedded system versus general purpose computing system, and we have studied what is the history of embedded system. So after covering these topics, we will go to our next topic, classification of embedded systems, major application areas, purpose of embedded system, characteristics and quality attributes of embedded system. So your textbook, Introduction to Embedded System by Shibu KV. So these are your objectives. So we have defined an embedded system and we have seen what is an embedded system from historical view. Then we have to do the classification and purpose and application areas we have to see. So we'll just refresh our topic. So yeah, you know what is an embedded system as of now. Embedded system is a unique system. It is consisting of hardware and software. It does a specific task. So I repeat once again, embedded system is a unique system. So embedded system designed for one application will not be used for another applications. Embedded system is having a hardware, a software called firmware and real-time OS. So real-time OS may not be used in all the embedded systems, but the three requirements are hardware, software, and your real-time OS. And it does a specific task. It is unique. So embedded system is an electromechanical system performing a specific function. It is a combination of hardware and software. It runs on its own without human intervention, and it may require to respond in real time. So these are the examples we have seen in our previous class. So digital camera, smartphone, vehicle automation systems, electronic toys, refrigerators, washing machines, smartphones, traffic light controller, mechanical system. So embedded system can be thought of as a computer system having software embedded in it. An embedded system can be an independent system or it can be a part of a large system. It is a microcontroller or microprocessor based. So you can use any one of them based system doing a specific task. So the task is unique. It is having a sensor, A to D converter, a processor, D to A converter, and an actuator. This all is internal to the embedded system, but externally it will have a sensor, input and output, one hardware, and one software program controlling the hardware. So this is what we have, and we have seen some of the examples for embedded systems. So the examples is washing machine. Another example is air conditioner system. And how an embedded system is different from a general computing system, we have just tell that it is a special purpose hardware and embedded OS, and it will have time critical system. It is a real-time system, real-time time critical system, and it is purely application specific. So this is the history we have covered. Now we'll just classify the embedded systems. As you know, these embedded systems start evolving from years to years. Each time new embedded systems got evolved from its previous system, having more features and advantages compared to the older one. So based on that, they have classified these embedded systems based on the generations, complexity and performance requirements, based on the deterministic behavior, based on the triggering. So these are the four methods of classifications. One is based on the generation. So if you see the classification based on generation, as these embedded systems start building, they are using a specific hardware. Okay, if that hardware is same for most of the systems, then they can have classified into one generation. Okay, the memory part, the processor, if it is same means a general purpose because general purpose processor we have used. in the initial stage. Later on, we have built our own processors. Like that, embedded systems, now they are having a special purpose hardware and embedded OS in it and doing a specific task. So first generation systems, based on the generation, these embedded systems are classified into 4 types. The first generation systems are called 1G systems. 1G systems hardware is a 8-bit microprocessor or microcontroller. It is having a simple hardware circuit and the firmware developed for it is also simple. So digital telephone pads, stepper motor control units are coming under first generation systems. So digital telephone pad and stepper control systems are first generation systems. Second generation systems are called 2G systems. They are built around a 16-bit microprocessor and 8-bit microcontroller. So second generation 2G systems are built around 16-bit microprocessors and 8-bit microcontrollers. They are more complex and powerful compared to your first generation systems. So the hardware part, it is some complexity. The software part also, they have done some complexity. So like that, those systems which are using 16-bit microprocessor and 8-bit microcontroller, they come under second generation systems, such as your SCADA systems, data acquisition systems. So SCADA systems and data acquisition systems are second generation systems. If you see the third generation systems, 3G systems, they are built around 32-bit microprocessor and 16-bit microcontroller. So your hardware part, it can be a 16-bit microcontroller or it can be a 32-bit microprocessor. There are some inputs and outputs. There is a memory, and we are using an application specific integrated circuit or DSP. What is an application specific IC? If you go for processors, there are processors like 8-bit microprocessors, 16-bit microprocessors, 32-bit microprocessors. Different vendors will produce same 32-bit microprocessors. So if an embedded system, if you using the 32-bit microprocessor, they can take from any vendor. But the concepts like application specific started evolving from the third generation itself. What is application specific? We are going to use the same 32-bit microprocessor, but the architecture part is application specific. We are not using a general purpose microprocessor. So general purpose we have used up to only third generation only. From third generation onwards, they started using application. If there is an electronic toy, okay, you can use general purpose. But if it is any flight control system, missile launching system, so their ignition control system, so there your hardware part must be having the logic specific to your design application. So for that, we started application specific integrated circuit. What is this application specific integrated circuit? It is nothing but in creating your own integrated circuit, creating your own processor. How you create your own processor? The design part of the application specific IC is analyzed and is created as a layout, and that layout is given to a fab unit. Fab unit persons are going to prepare your own IC and they are going to give, like there are multiple vendors. So a Samsung company, if refrigerators are manufactured, so all Samsung company, all refrigerators coming under Samsung company, they can use their own IC. So they can create your own chip instead of using a general purpose or any available vendor 32-bit microprocessor. They can use an ASIC or they can use a DSP. So what applications are coming under second generation is robotic, media, industry controlled process, networking. So these all devices used in robotics, media, industrial control, process control and networking, they come under third generation systems. And the next is fourth generation system. Fourth generation systems are those which are built around 64-bit microprocessor and 32-bit microcontroller. So you are building it around 64-bit microprocessor and 32-bit microcontroller, and the concept of system on chip and multi-core processor, like we study in our smartphones, quad core, dual core, multi-core. So here the concept of multi-core processors evolved, and system on chip means your processor, your design part. If you see the earlier televisions, they are using one CRT tube along with some different designs of like RF amplifiers, IF amplifiers, like that. Now, if all RF amplifiers, local oscillator, IF amplifiers, mixer circuits are all part of a single board, then that is called system on chip. And the display is also now LCD or LED. So like that, your televisions become compact, and they are using SoC. SoC means a single printed board will have all the design part of RF amplifier, mixer, IF amplifiers, modulation part, everything, demodulation part, because your television is a demodulator, it is a receiver, not a modulator. Okay, so, and these 4th-generation systems are called are using SoCs and multi-core processors. They are highly complex and powerful. So they are highly complex and powerful. So examples like your smartphones and MIDs will come under 4th generation. So we have we are having certain embedded systems, but based upon the hardware part, they are classified into 1st generation, 2nd generation, 3rd generation, 4th generation. And next classification is based upon the complexity and performance. So based on the complexity, the embedded system used for missile launching system is more complex because that must be a time critical and real time system. The embedded system used for an electronic toy may not be time critical, may not be deterministic. If it is delayed, the application provided by an electronic toy, if it is delayed also will accept. But if missile launching, if there is a delay, will not accept. Airbag control systems in car automations, that is also deterministic and real time. They must behavior as exactly provided by the application software. So there is one more classification based upon the complexity and performance. They are of 3 types. Small scale embedded systems. What is the small scale embedded system? They are very simple, they are not time critical, low performance, low cost, and may or may not use OS. Okay, such as our example is electronic toys. So these electronic toys are coming under small scale embedded systems. Medium scale embedded systems, they are slightly complex in hardware and software compared to the small scale. They provide medium performance, they are having low cost, they usually contain OS for functioning. So example is industrial machines. So these industrial machines come under medium scale embedded systems. So the next classification is large or complex scale embedded systems. They are highly complex in hardware and software. They are using 64 or 32-bit RISC or CISC processors. They may contain multi-core or quad-core or dual-core processors, co-processors. They are using real-time OS for task scheduling and assigning the priority. So if there are multiple requirements in tasks, multiple tasks occurring, so it has to schedule. First, initially RTOS will schedule which task must be completed or which task must be done, and after which task must be initiated. Then based upon the real-time input taken, it will assign the priority. It will shift the priority to the task. Task 4 maybe will be done second, it given the task 2, or it may be given task 3, or it may be performed in task 6. So that priority to the tasks will be given by task scheduling and priority, and that is done by the RTOS, real-time OS. And the examples is mission critical applications. All mission critical applications will come under large complex scale embedded systems. So there is one more classification based on the deterministic behavior. So if you are seeing our classifications, first one was based upon the generations, second one was complexity and performance, third one is deterministic behavior. What is deterministic behavior? If your embedded system is behaving as exactly as prescribed by the manufacturer, it is called deterministic. This application, why it is meant is your real-time systems require that they behave as provided by the manufacturer. The task execution behavior for an embedded system generally may or may not be deterministic. So it may or may not be deterministic. So based on the execution behavior, these real-time systems, actually all real-time systems, we expect that they must be deterministic. But sometimes these real-time systems may not be exact in their behavior. Slightly they are non-deterministic. In such a case, again, these real-time embedded systems are divided into hard and soft. Missile launching system, they come under hard real-time system. Flight control system, soft real-time systems. Okay, landing. At what time you have to land it? Due to there is a temperature effect or humidity effect, you are unable to um, land your flight in time. Slightly deviation in nanoseconds or seconds. That is called soft real-time system. Whereas missile launching system, that must be coming under hard real-time system. Both are having deterministic. The result is deterministic. At what time you started the flight, at what time you have to land, that is deterministic. But if you take some time in its operation, that is called soft real-time system. But missile, if it is once it is launched, it must hit the target. That must be deterministic. So another classification is based on the triggering. So based upon the input triggering, they are classified into two types, event triggered. So those activities within the embedded system which are dynamic and depend upon occurrence of the different events, they come under event. So depending upon the event, they are triggered. They are this embedded system is a big system having linked to so many subsystems. So depending upon the events, one or more other small applications get invoked. So these are depending on the events. Or these embedded systems can also be classified into time triggered. What are these time triggered? Activities within the system which follow a statically computed schedule. They are allocated different time slots. At what time what application must occur, and that is decided by the design and by nature prediction. They are allotted time slot. So coming to applications, as we told, these embedded systems are used in all the sectors without their knowledge. We are the end user is using and he's having the performance and its features, comforts, he's utilizing it. So like that applications, if you see, these major applications are in televisions, stereo, remote control, phone, mobile, refrigerator, microwave, washing machine, electric toothbrush, oven, watch, alarm clock, electronic musical instruments, and electronic toys like stuffed animals, handheld toys, pinballs, medical home equipment like blood pressure thermometer. So these are the applications areas where your embedded system is utilized. Applications of embedded systems, that was generally all the systems which are coming under embedded systems. But even then in certain systems all are used in a specific area, so they are classified depending upon the area. So application of embedded systems are the products are classified are countless. But if you see the consumer electronics, the consumer electronics means the camcorders and the cameras, they come under consumer electronics. This is the embedded system coming under consumer electronics. Household appliances, washing machines, refrigerators. Household appliances, it is washing machine and refrigerator. So what a washing machine does, you know. What a refrigerator does, you know. Next, automotive industry, anti-lock braking system and anti-lock braking system and engine control. So another embedded system application area is automotive industry. So this is related to application area. Under that applications where there are large number of embedded systems. Anti-lock braking system is one embedded system logic. Another is engine control. So you have to apply the locks once it is landing. Once flight is landing, it has to control the tires so that locks are applied and slowly it lands onto the floor. So home automation and security system. So air conditioners, sprinklers, water sprinklers, fire alarms, they come under security, home alarm, home automation and security. There is one more classification called telecom, cellular phones, telephone switches. Another area is computer peripherals, printers, scanners. Another area is computer networking system, network routers and switches. So computer networking systems means network routers and switches. Healthcare, EEG and ECG machines. So this EEG and ECG machines are coming under healthcare. So this is one classification of embedded system where electrocardiogram machines are used. These are related to devices under healthcare. Under banking and retail, we are using an automatic teller machine as one. Point of scales is one. Under card readers, barcode and smart card readers. So these embedded systems are inevitable in having inevitable products, and they are used in all the areas. But there are no more number of embedded systems coming in a specific area. So we have classified them into consumer electronics is one area, household appliances is another area, automotive industry is another area, home automation security is another area, telecom is another area, computer peripherals is another area, computer networking system is one area, healthcare system is another area, banking and retail is another area, card readers is another area. So like that, we have classified so many embedded systems. They have evolved in all the different areas. So with this, we'll stop our lecture. We'll cover the remaining topics in coming classes.